So now when we get to graphing linear equations, if the equation is not in a form y equals mx plus b, it's really nice and convenient to get it into the y equals mx plus b form, because then you can easily find the slope and y-intercept and graph it from there. So with this first equation, you can see that y is not isolated, so we just want to solve this equation to get y alone. So the first thing we want to do is subtract 4x from both sides. You would end up getting that 2y equals negative 4x, because you just have 0 on that right-hand side. And then you just divide by 2, and you're going to isolate y. So you end up getting that y is going to be equal to negative 2x. So you can really treat that as negative 2x plus 0 if you want, which is going to tell you that 0 is actually going to be the y-intercept. So because this right here is a 0, then the y-coordinate there is going to be a 0, because we always know the x-coordinate of y-intercept is going to be 0. And then we know the slope is going to be negative 2. So if we graph this, we know the y-intercept is going to be at 0, 0, and then the slope is negative 2, which tells you have a rise of negative 2 and over 1. So just like this is going to be a line with a negative 2 slope, and of course passing through the origin. So that's going to graph that particular line. Of course, you can tell from the graph that also the x-intercept is itself going to be also at the origin at 0, 0. And then right next door there, to isolate the y, I'm going to add 2x to both sides, so we cancel that out first, and that's going to give you negative 6y equals negative 3x plus 18. And then if you divide by negative 6, and you divide by negative 6, you're going to get a positive 1/2 x, and then a negative 3. So that's going to tell you then that the negative 3 is going to be where your y-intercept is, which will correspond to negative 3 right there on the y-axis as being a point on your line. And then also you have the 1/2 that's times in with the x, which will tell you the slope of the line. So the slope will be a rise of 1 and a run of 2, which you see like this accordingly. So now with that all sketched out, you can also see that based on our graph, we did get a very nice integer coordinate for the x-intercept right there of 6. If you didn't know that, you could know that there's going to be a 0 always for any x-intercept, and then you could plug in 0 in for y into the equation. So 0 equals 1/2 x minus 3, and then solve for x. So you can add 3 to both sides, giving you 3 equals 1/2 x. And then times both sides by 2, and that tells you that 6 is equal to the x-coordinate, which of course we can see. So then we know that the x-intercept there is indeed at the 0.60. There's a couple more examples here. So at the left-hand side right here, we just really need to undo the 1/2 to get the y alone. So I'm going to have to multiply this side by 2. And then because there's a couple terms on there, you need to distribute that multiplication of 2 to both of these things right here. So when you do 2 times negative 7/8, you end up getting negative 14/8 x. And then 2 times 1 is plus 2. You can reduce down the negative 14/8. It reduces down to negative 7/4x and then plus 2. So because of the plus 2, you know your y-intercept is going to be at a positive 2, so that's going to correspond to that starting point right there. And then it does have a slope of negative 7/4, so if you go down 7 and then over 4, you're going to land there. And then if I go backwards, 7 and over 4, it'll land there. So that's going to give you a sketch of what the line is going to look like there. I should note the slope as being negative 7/4. And then it looks like the y-intercept is probably not the nicest of numbers, so to be able to find, or the x-intercept, is not the nicest of numbers right there. So to find that x-intercept, we know that the y-coordinate is going to be 0. So we're going to substitute 0 in for y into the equation then, and then solve for what the corresponding x value would be right there. So if we subtract 2, then 2 is equal to negative 7/4 x, and then we'll have to multiply by negative 4/7 to get just a positive 1x. So if I multiply that by negative 4/7, you're going to end up getting a positive 8/7 for x. So it does turn out that the x-intercept is going to occur at 8/7, comma 0. And then for the equation over there on the right-hand side, to isolate the y, I'm going to first of all add 3/4 and add 3/4 so that we get 3x plus 3/4 equals negative y, but we want to have a positive y, so just multiply both sides by negative 1. So you do end up getting negative 3x minus 3/4 equals y, and that is now in mx plus b form. So the coefficient of x there is negative 3, so that'll tell you the slope, and then negative 3/4 is the y-intercept, so 0 comma negative 3/4 will be the y-intercept. So in this case, you do end up with a fraction for a y-intercept, which is a-okay. We know that negative 3/4 is basically going to be right there, almost to negative 1. And so then if you're going to graph this, we know the slope is -3, so if you go up like 3 units and over 1, you'll kind of end up at a point that's also at like a fractional point, but that's totally fine and okay. And then you just go up 3 again from there and over 1, and up 3 and over 1, just like that. Down 3 and over 1. So you get the idea. So from that, then we want to be able to find where that x-intercept is also going to be landing at right there. So we do know that the x-intercept is, of course, going to have a y-coordinate of 0. So if we did substitute in 0 in for y into the equation, then we can add 3/4 to know that -3x is going to be equal to positive 3/4. And then we can divide by 3, or we can also, or -3. Or we can also think, let's multiply by -1/3, because that'll equal 1x. So if I multiply this by -1/3, you're going to get -3/12, which then reduces down to -1/4. So that's going to tell you then that the x-intercept of the line is going to be at -1/4, 0.